Hello, everybody. I think we should be about live here. I'm just finishing up real quick the last couple things I need to do to have us be actually ready. Because like I said, we're a little bit early today, which is good, right? We got a lot of progress last week, and it's time to really get a chance to dig in and take a look at it. Oh, I need to change the text down here. The current status is Numpy writing exploit. And the next stream is Wednesday. I think what we're going to be doing next week is going to be triaging crashes, because hopefully we will have this landed and ready to go. Or not next week, next stream, we're going to be just triaging a few of these crashes. So, as far as where we are right now, that's interesting. YouTube sent me a push notification to let me know that I've gone live to stream. That seems a little bit counterproductive, but okay, YouTube. Thanks for that one. Where was I? Right. So we currently have an arbitrary read and write using these. Let's see here. Where are they? Projects Python. Do we have a version in here? No, we left them in the Python. No. Where did we leave them? So we have an arbitrary read and write in the two functions. They are called getField and setField on a NumPy array object. Basically, the way that these work is getField accepts 3 arguments, which will be getField accepts 2 arguments, and it acts on a. Hello, Giovanni. Thanks for tuning in. So getField acts on 2 arguments. It acts on a NumPy array, and it will accept. Why don't I show you rather than just talking here? So give me a second here. We're gonna get this set up properly. Okay. Split.py. Import numpy as np, and we're going to do a n is equal to np dot array. I think that's the right way to do it. And then n dot get field. The first object needs to be something that's a size, and trying to remember the right way to do an int 32. So there was a. Let me figure out where that got to. So after the stream last week, a few people did some further research on the crashes we had, because one of the arguments to this is a size of the thing that we're trying to read. Looks like it was on Twitter. And basically, they went through and they figured out that. No, I don't want to log in as that account. Well, here. There was a object that you could pass in, which would be a just an integer that you were able to read and write. Oh, it's actually you. It's actually Giovanni who mentioned this. So if you use the np.int32 here. Yep. That was super convenient for coming across that. So we want to do a np.int32, and then we pass in an offset to read and or write from. So this is the get field version of it. I believe this works. Requires an object. np.int32. What does this do? I would expect that to crash. Why did that not crash? Interesting. If I understood how this worked, this should have crashed. Hmm? There we go. Why wasn't the get field crashing on me? Oh, are we just coincidentally hitting something that is there? If we look at this, we are trying to write to RDI. That's weird that it was doing it that way. But in any case, this is the primitive that we have, right? It's actually trying to read and write from an object that we basically control. We can find out the pointer pretty easily, and of the thing that we're an offset from, and then it's just going to let us read and write to it. It should be super simple to try and land this now. By super simple, I mean it's going to take a fair amount of work, but, you know, straightforward at least. So, before we get started with that too much, just real quick, I'm going to point out that if you... and... believe that this should work. Why? But for whatever reason, OBS does not want to give me Chrome as a window. Okay, in this case, we're going to oops, sorry about this. We want... let's make that go away. We're gonna get here, guys. Properties, I believe we want... not that one, this one. There we go. So if you have not already seen it, Gamozo posted a stream yesterday on using the AVX 512 implementation to optimize his fuzzer. If you're interested in very, very high performance fuzzing, I definitely recommend taking a look at this. He's doing some very interesting things with using the vectorized instructions to basically... it's pretty hard to explain. He explains it much better than I do. But the short version is he's using these vectorized instructions to get much higher performance than you would if you were doing things normally. He's able to emulate things and get some really interesting results out of it. So if you're interested in a highly technical talk on doing high performance fuzzing, specifically with a very relatively obscure processor feature, check it out. It's about 3.5 hours long, and it's definitely worth the watch. So I posted the link in the chat. Would recommend checking it out if you have the time. So we've talked about that. I guess before we go too much further as far as useful announcements for people, because there's A few things going on in the near future that are probably well worth keeping your eye out for. This weekend is going to be this weekend's going to be the launch of Labyrinth. Actually, you know what? I can pull these up while I'm talking, because I can just use that display capture. There we go. Right, so the not this one. Labyrinth kicks off this weekend. So this is a it's a CTF, but it's a little different than most events usually are. So it's supposed to be played individually. It's run by Palo Alto Networks, and they have, I believe, 5 tracks, something like that. And yeah, we can actually go to it. We can actually take a look at that. And of course, they've got this, cute little bash-like, command line interface to get, the readmes. But anyway, there's 5 tracks. They're on reverse engineering, threat intelligence, programming, other stuff. And it's also very long running. So the intention is to do it individually, and it's very long running. It goes from this weekend all the way through July 23rd. They've got a bunch of cash prizes. Last year they sent out challenge coins to people who completed different tracks too. This launches this weekend is when it starts. And then the weekend afterwards is going to be the Google Capture the Flag. So looks like June is the month for well-funded corporate CTFs, because both of these are being run by large companies as opposed to the relatively normal CTF teams that run most competitions. So both of them should be interesting. I'm definitely going to take a crack at the Labyrinth stuff. One thing that I'm thinking about doing is actually trying to record all the streams, or record all the work I do on Labyrinth, similar to the way that I record these streams, and then after this is over, so July 24th or whenever, actually play them all through as a recording. I don't know how much progress I'm going to make on it, but I assume hopefully over the course of the month and a half this is running, I should make some good progress, and so we'll see how that works out. If it'll be less interactive than these streams are, but it should have a little bit more of an idea of what my process is when I'm presented with problems that I don't know what I'm doing with. Because for these streams, I do at least a little bit of prep work for them, although very little, as you can probably tell. Because I like to have things be as kind of authentic as possible, because I really think there's a lot of value in seeing how people do things when they aren't quite sure what they're doing. So in case, I'm planning on recording this stuff from Labyrinth and eventually posting those as streams and or videos. We'll see how it works out. So yeah, I think that's about all the stuff that's happening in the very near future. There's while we're here, this is the stuff that Giovanni posted, and it's of course there we go. Very helpful. He basically found out that he poked around with it and he found out that there was another type that we could use here, this np.int32, which just straight up writes 4 bytes into the address that we give it. So rather than all the goofiness we were doing with converting to a double to get the value we wanted written, you're able to just straight up say, I want to write this many bytes to this offset of the array. And it just works. So thank you, Giovanni. That is great work, and it is much appreciated. So I think it's about all that I have to say about things. Here, let me post this link too. And I will also retweet it again. Oh, I can't retweet it again because I'm not currently logged into Twitter on this machine. Well, that's fine. I will retweet it after the fact. Let's get rid of a few of these windows. So, where were we? So the task for tonight now is to take the read and write primitives that we have, and basically turn them into a full-blown exploit for Python. And while we're at it, one of the things that I'd like to do, and let's actually write some notes about this while we talk about it. Where did that end up going? The downside to having many monitors and not quite being sure where exactly we are. So anyway, the plan for tonight is read primitive, write primitive, and then write an exploit that uses them. And so when I say a primitive, what I mean by that is we currently have this thing here. We have this set field thing, which is going to let us write some bytes at a given offset from this NP array. And while that works, and that's definitely as far as I would do things on a CTF, like I might go to a little bit more of a stage farther than this, but for kind of real world things, it makes a lot of sense to wrap all this up. And what I'd like to have, where are we? How do I keep getting lost here? What I'd like to have is I'd like to define a read address length function. I'd like to have a function here that is going to return, some number of bytes to me. And the idea here is that I can then take this read function and I can make a very generic looking exploit. And then I also have a write function, which accepts a address and then just a string to write into memory. And that's both of these, if we set them up properly, should be very generic, very simple to use, so that when it comes to it, I can then come down here and I can say, print, I want you to read from 0x41414141 4 bytes. And then that should just straight up read 4 bytes out of that address. And I would do write 0x41414141 and, 0xCOCOCOCO. Is that the right number? Yeah, that's the right number. C's. That's what we'd like to have. So the first thing we're going to do here is we're going to kind of genericize those primitives. We're going to write this read and write function, and then we're going to take those and then make an exploit that uses them and should hopefully be pretty generic and pretty straightforward to use. And let me see here. All of these windows are getting a little bit confusing. I'm trying to keep track of everything here. So I think that's a good explanation of where we're going to go. Before we go too far, however, let's go back a few episodes. So we were posting this link every time, and there's actually some discussion. Oops, not this one yet. So in this post, let's post this again over here. We kept referring to this because this post was the this one right here was the kind of start of the idea of this series of streams. It was a guy who was doing some pen testing, I believe, and he found out that he was looking at some sort of sandboxed application where he was able to write arbitrary NumPy. Basically, he went through, he found something that caused a segmentation fault in it. In his case, it was also in some of the array stuff, but the resize functionality, he was able to take advantage of that. So there's also some discussion down here about doing things that are interesting here. One of the first ones that's very important here is the ID function. We're going to take quite a bit of use of this. So the Python ID function will return the address of the object you call it with. So if I do, you know, A is equal to A, B, C, D, E, and I do ID of A, or hex ID of A, this is actually the address in memory of that A object. And when it comes to, you know, exploitation on, you know, reasonably modern systems, being able to get the address of anything we want. Oh, hello, disconnected. Being able to get the address of anything we want is super useful. We're going to be able to turn this, along with that read, into, because especially because our read is a arbitrary, but I'm blanking on the word here. It's an arbitrary read, but it's a relative read. We don't just say here's an address. We say here is the offset from an object in memory that we want to read from. So the short version is that ID turns that into an absolutely arbitrary read. We're able to just take ID of the object, that array that we just initialized, and use that to read out some bytes. Oh, I said all of that, and I typed it in over here, but of course I didn't switch screens so you could actually see it. Sorry, my bad. So we have this. There's some discussion about memory allocation. I don't think that matters too much, but the PyObject stuff I think is going to. When it comes to actually trying to do our exploitation, we're probably going to come back and refer to this a little bit more. I don't think any of this is immediately useful. So he uses C types in order to get a read, write, execute region mapped in. It is partial rel-row, which is fine. It's not pi, which is basically what I expect. There's this copy thing that we kind of interacted with last time a little bit. Interesting. So the way that he exploited it was just to remap fwrite to system, which is not quite exactly what we want to do here. We want to do a little bit more than that because we want to be able to run arbitrary shellcode rather than just pop a shell. So we're going to have to do a little bit more work than that. So, let's start by giving it a try. So the first thing we need to do here is we need to write this read function. So we should be able to do n is equal to np.array. Sure, we can do this. So one thing we need to do is, I'm not sure why pass the first thing we had here, which was n.getField of np.int32 ox41414141, why that didn't segfault. I mean, I want to return that. So I would expect this to segfault. Oh, it did segfault. x/x $RDI minus ox41414141. It would appear that I just can't type. And I want to do a x/I rip. No, we are definitely writing to this. Oh, because we're still segfaulting up here, aren't we? Print hex ID n. Okay. Not sure why it wasn't working the first time we tried this. So if you recall when we were first writing some of this out, we didn't get that segfault, which is a little weird. So if we do, so we got this address right here, and if we do an x/x of, x/x, that looks good, and an x/x of RDI minus ox41414141. Ooh. Oh, it's RSI. I'm gonna say, Are we getting tricksy here? So we're not quite getting the... So we're running into the same thing that we were seeing before. That ID is getting the copy of it, where we're actually returning a... Sorry, I'm blanking a little bit here. While we're getting something slightly different. So we're going to have to think about this for a second, right? Because at this point, we don't have a straightforward way of getting the address of this object. Although, let's see if there's one nearby. x/20gx $RSI, or we still have it in our paste buffer, don't we? This thing. So this is what ID gave us. And ID this doesn't directly help us, right? ID gives us the address of this copy, and we know that a certain offset from it is going to be the thing we want. But it's not directly giving us the address. And until we have an arbitrary read, that doesn't help us. So what about x/20gx RSI minus OX41? Let's put this into our paste buffer, and we want to start a few bytes ahead of it. So this right here is our heap allocation. This is the size metadata, because we're just using standard malloc. We can see here that we're actually overwriting, that it's not actually initializing this, which is a little bit interesting. So because it's not initializing it, and so we know it's not being initialized because the pointers here are still here. These would be the next and previous pointers, probably in a free list at some point. That's not necessarily true because given the size of this allocation, the 21 hex bytes, it wouldn't normally have those pointers. Not to mention that those pointers are to way up high in memory, this other set of addresses. What is this second one here? Oop. Oop. Jeez, I'm just not typing well at all right now, am I? Yeah, that's pointing back at the free list stuff. So that's interesting, but it doesn't directly help us. So let's think about what we're going to do here. So one thing we can do here is we can try and figure out how to get ID to return the right thing, which is one approach that'll work. Is there another approach that makes more sense? We could search for something that looks right, but that's a little bit unreliable. So let's see here. I'm curious. If we do that, it prints out the same thing every time. Oop, no. Hopefully that didn't just break everything. Yes, rerun it. Import numpy as np, n is equal to np.array, abc, id, n. We want to get a hex value of it so we can actually understand what it says. So see, this would appear to me that we are getting the copy of it and not the object we actually want. So n dot hex id n. Nope, still the same thing. N dot to string dir hex ID n. No, we're still getting the same thing. B is equal to n dot to string. It's interesting it's still giving us the same thing here. Am I maybe making some bad assumptions here? Because I am making some assumptions. No idea if this helps, but you might try. It's a good idea. So disconnected there is suggesting that we dump some of the other properties of it. It's not a bad idea. Does this get us, like, are we just looking at, n, we want this. We might just be lucky enough that, no, we aren't that lucky. Also, the Python shell makes a bit different stuff from normal execution. Yeah. I mean, realistically, people should not be relying on ID at all. At least hopefully they aren't. So I was hoping array would maybe give us the... What's array interface? Yeah, you know what? We will... For kv in n dict items print kv id hex id v. V? V. In n dot array. So there's a couple ways to do this. But I don't like any of them. Say function. And 1 is equal to n dot copy print hex id n n1. So what's odd here... Oh, no. What's odd here is that the address we're getting is definitely not where I want it to be. My guess is that we're getting, like, the wrapper object. We're getting the ID of the wrapper object as opposed to the... Like, there's a buffer in there that it knows about, but we're getting the wrapper object as opposed to the, like, actual buffer, which is where we're getting our offset from. So... Can we get that? I'm looking through all these. So if we use... Because ideally, they're one of these, like, magic functions is going to just give us that buffer, but it doesn't look like we're that lucky. How about... What does that do? Print hex id n.data. Nope, that still isn't what we want. In fact, that's not even close to what we want. This is unfortunate. I was hoping this would be a little bit easier to figure out. Because, I mean, ID gives us this great primitive to leak stuff out. But it appears that we are not quite that lucky. So, x/20gx, $RSI, minus OX41414141. This is where we are. And one thing we can take advantage of is we could try and take advantage of the fact that we know there are going to be certain objects before and after us in memory, because it's just order of allocation stuff. So if we do minus OX60, so this is where we are. Fortunately, this does not look particularly useful either. What is that? Like, is this some documentation code there? Well, that's... I was hoping that'd be a lot easier to use, but apparently that's not going to work out quite the way I was hoping it would. So, we can't force the garbage collection here. We could wrap this around something and kind of force it, but I don't like the way that would work. Man, not being able to... How did this guy do it? So ID can be unreliable for reasons that it can't determine. Python appears to pass a copy of the object while the original object is used. Yes. Yes, clobbering metadata is going to be difficult. The region where objects is allocated is somewhat unpredictable. Well, that doesn't actually tell us very much at all. And then he uses... Oh, he just creates a bunch of arrays and uses one of them? Yeah, I guess that works. What if we do this instead? Nope, scoping doesn't change anything. So I was hoping here that if we change the scoping, that might force it to do what we wanted. What about if we initialize it differently? One. So it is interesting to see the difference in how these are stored, But it's not directly jumping out as being all that useful. Wait, what am I saying? How reliable is that? Because that right there is a pointer to nearly our buffer. $RSI minus OX41414141. I like the looks of that. Check this. And we have a gist. I never know how to actually pronounce this. 404 cannot be found. Switch over to this. Try this. So we take this, yeah. Yeah, let's just copy this code and see what happens. Nope. Set no auto indent. There we go. Indent does not match. Oh, how did that happen? Right? Yeah. Function type not defined. Oh. From type, I should just copy and paste this. Show us the console. Oh, yep, sorry. Okay. Ooh, base is interesting. Flat is also interesting. X/X RSI minus OX41414141 is at 33F70. So none of these directly line up with it, but it is interesting. Wait, NumPy straight up gives me C-types? Is that real? What did it just return? What is that? Oh, let's not initialize it twice. Print hex n.ctypes.data. OX41414141. Of course. Of course that's a thing, because NumPy. So in order to be helpful when we are transitioning between C-types code and Python code, we can just straight up access the pointer of the buffer we're going to read and write from. Yep. Yeah, the ctypes.data there is... I can't believe this is true. It's just the pointer. As a Python integer, of course, because that's the way you do things in NumPy. Okay, so now that we have that, we can get rid of all of this. So base adder is equal to that. So if we want to read 4 bytes, you know what, let's not accept a length. Do we want to process length here, or do we want to process in the exploit? Let's process it here. Makes it easier, right? So when we do a read of this, this needs to be... So offset is equal to if address is greater than base address. Let me think about this for a second. So we're going to add the offset to base address. So offset is equal to address minus base adder. We do offset here. Signed integer is less than minimum. That's unfortunate. Oh man, grabbing a bear would be very exciting. If offset is less than 0, offset plus equal 2 to the 64. Oh no! Well, that's interesting. That may be may make things difficult for us. Oh. Offset and equal 2 to the 64 minus 1. And we want to turn auto indent back on. Oops. Too large. Print hex offset. What is this? Print hex base adder. This plus this. So that works. Unfortunately, it's too long, too large to convert to a C long. So this is going to be a little unfortunate because it's looking like the value we can add to this has to be a 32-bit int, because it has to be a long. So let's think through this for a second. Actually, you know what? We have the source code for this. So when we tried to go negative here, what happened? We got a signed integer is less than minimum. Python or projects NumPy source, because conveniently, what did I call this? NumPy? Yeah. Where is this thing? Oh. Oh no! Okay, let's see if we can find this. Oh, right. Of course it's not going to be like that. It's going to be just the string here. Interesting. What does Google have to say about this? Oh, let's pull this over so we can actually see it. Google has to say that wait, what? By the way, you can do git grep. Yeah, yeah, I'm used to actually ripping out the git stuff when I look at a lot of source code. Because I only care about the current version, so if I delete the .git, it will help make it a little bit faster. Okay, well that is not entirely helpful. So that's actually a Python error, it looks like. Yeah, there's also a little bit of a delay on the stream. Despite there's a few options I can turn on with YouTube, it's still going to be a slight delay between when I do something and I actually see it typed. So like if I go and I type in the chat and I say, look at this, you could see it's, 5 to 10 seconds round trip just from my machine to it coming up. So best case scenario, when you're watching this, you're at least 5 seconds behind. Potentially much farther behind if you have latency on your end, or YouTube does some weird stuff with like buffering. Tries to buffer it to make it smooth for the person watching it, which may or may not be low latency. But well, so let's think about this again. So we're looking at this code. If we go back to what we're doing here. We have the base of the object we're writing to. So what is the... So the error we're getting is signed integer is less than minimum. I'll give you back the Chrome window. I do appreciate somebody else using YOLO all the time in their code. No. Nope, that's where we were before. Okay. Let's try this the other way. So 4 is where this was. We also have the Python source. You should be in there someplace. Yeah. It's in getArgs? Okay. Python getargs.c 717. So if ival is less than int min, what? Do I not have... Oh. Python, and I have tags here, right? I don't have tags here. ctags-r dot. So we did this before when we were looking at this, but for people that are unfamiliar with this, we're using ctags to make looking at source code much easier. So we're in case I here. No, we're in here. So int max. Sorry, we want int min. Int min. Yeah, int min is unfortunately the 32-bit minimum. Because hex of this thing, yeah, it's a signed 32-bit int. Okay. So we have to be smaller than that. What's the other error we get? So we also tried plus OX or plus OX or 2 to 64 and 2 to 64 minus 1. There we are. So now this is Python int too large to convert to a grep -rn. We want to find this thing. It is in long object. Long object.c337. If overflow. By long, as long, and overflow. Could be cute and give a different message for overflow is equal to -1. Okay. What does this thing do? So it sets overflow, I assume, if we would wrap back around. And so this is going to be tricky. So that doesn't mean that we can't do exploitation. Like, we can still do the same type of exploitation we would do normally. It's just that we can't do it with low values. Which I suppose works fine. So one thing to consider is we're running this in GDB, which is forcing our heap to start at that OX 5555555 address. So we're starting at this address because we're running in GDB. If we weren't running in GDB, the heap starts at different addresses. And off the top of my head, I'm not actually entirely sure what they are. Projects, Python, exploit, Python exploit.py. Still starting a pretty similar address, though. It's still starting at a 5.5 address. Which is definitely unfortunate, right? So that means that we can only have a negative 32-bit integer. So the lowest value we can go to is, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 558C in this example, which isn't super useful. So the issue that we're running into here is that we're not going to be able to read or write into the I'm blanking here. Into the Python stuff. Well, we can do this the kind of janktastic way of doing things. So we're going to have an arbitrary read, but the value has to be greater than where we are. And if you remember when we first started looking at this, it isn't initializing the buffer. Yeah, we can try it that way. Is int64 a thing? Now, this would be this is definitely one of the places where not knowing so we do have an int64. Not knowing what's an int0? Not knowing NumPy extremely well prior to this is kind of hurting a little bit. What is an int0? So that's a long. Okay. Well, that's a good sign. Python int too large convert to a long. But if we get rid of that. Nope. Still using the same path to get there. But what I was saying was, we do have another option here. It's a little bit messier, but we can use the wonderful, wonderful tricks that are the libc. So if we walk back a little ways, so we're going to take this right here. Actually, let's make this something identifiable. So ox41414141. We're going to do this. And we're just going to say offset is equal to address. Oops. Get rid of there, get rid of that. So, address not defined. Oh, it helps if I can type. So, we get our segfault. We are now in an unaligned read. We're trying to read from RSI plus RDX times 1 minus 8. That's a little bit different. That's really different. Wow. What have we done? What? That's all sorts of broken. Ugh. In strided to strided size 8, raw array assign. So we have Jeez, that's if we do this with an int32, we still have this wacky x/I rip. How did we what have we done differently? I guess because we're using a array here, it acts very differently. RSI minus OX41414141. It's like that's definitely the right thing, but why are we adding RDX to it? That doesn't make any sense at all. Like, does that just straight up fail? Well, let's go back to the thing that we knew worked. This thing works. Right, RSI x/x or 20x RSI minus OX 41414141. Right. So, oh no, that's not getting us what we want at all anymore. So now we're running into a different issue. What I was hoping for here is that we could use the next pointer. So we've got these pointers here that are pointing backwards and forwards in that doubly linked list that are free blocks. So what I was thinking here is that the libc data section is always going to be way high up in memory. It's just the way that works. Because it gets mapped in, it's always going to be way up high in memory. So we should be able to bash it without much of an issue at all. But it looks like we're not quite that lucky. Because it looks like we're going to have to do things the right way, I guess? That seems weird. So we only get positive addresses. If we get an address to the libc, we could work off there. But right now we don't have an address to libc that is directly accessible. What else can we use here? So one thing that's interesting is it looks like if we initialize that with... Let's actually give that a try, because I'm more than a little bit curious here. Over here. There we go. 0. Like, does this just straight up segfault? No. What is going on here? If this is over a certain value, we fall into this other code path, it looks like. And... what? I'm so confused. What is this code path? Because this is clearly wrong, but it looks like it's only if it's over a certain size that it falls into this. And like, this could never be right. It's adding 2 pointers together, it looks like. And we know that that's not going to be right. So what options do we have here? So we've got this, relative read that we get a arbitrary relative offset to, which gets us a little bit. But it's a little bit unhelpful if we don't know what the size of the heap is. And based on the way that Python does their garbage collection, I don't know if we can rely on the garbage collection to actually free things, because we don't have direct access to allocate and free things. We can create objects, but we can't necessarily free them whenever we want. So we might not be able to directly take advantage of that either. The upside is that if we were dealing with if we could just shove any value we wanted into there, we could pretty straightforward, pretty easily, and sorry to derail here. This is me being a complete moron. I thought that was saying RSI plus RDI times 1. That is RDX, which is times 4. This is totally just being completely dumb about this. This is doing the same thing I thought it was, and I just can't read. Whoops. That is my bad, guys. Sorry about that. This is not some bizarre computers just don't make sense situation. It is I can't read, and they make pretty reasonable sense, I guess. That works the way that it seems like it should work. It is a little interesting. So a NumPy array has both a NumPy array has both a object and a size. So how does that work? If we say this is a int 64. I didn't do quite what I wanted. What I was hoping for here is that RDX would end up like we could do something with the multiply there, but it doesn't look like we actually can. Although, can we take advantage of it? Where are they doing the comparison? Well, that's definitely interesting. Oh. Oops. Actually, you can specify dtype, which is data type. I believe is the second argument. np.int64. Oop. And n. Well, this isn't getting us anywhere quickly. By the way, I should use IPython. Yeah, I probably should learn how to use IPython. It's something I've avoided quite a bit, mostly because it's scary and different, and I tend to try and use things that are installed by default on systems as much as possible. I've been burned a few too many times on I learn how to use a thing, and then I go to work on a system that isn't mine, and oh no, I don't have the thing that I learned how to use. Whatever will I do? So as much as possible, I try and use like default stuff. So like the default Python, the Vim with no plugins, GDB with no plugins. I'm a little stumped here. Because, so we're running into this issue that we can't have a negative value that's large enough to do anything useful, right? That's true, right? iproc mappings. So, am I full of shit here? Maybe I'm full of shit here. We can actually totally hit that. Vim is not installed by default on Ubuntu. However, VI, the minimal Vim, is, and it's relatively usable. Plus, it's a lot easier to say, if you want me to do work, I want Vim installed, than if you want me to do work, I want Vim plus this list of plugins installed, or some other, like, I want Emacs with this configuration set up. It's actually the reason I've avoided Emacs, is because it takes a lot of customization to be usable. Like, every person I know who uses Emacs uses, like, a crazy customized environment for it. And I change computers too often, and I don't want to have to carry environments around like that. So, ulimit-c unlimited python split gdb. Oh, right. Which python? Core. Interesting. Very interesting. So, I apparently made the very bad assumption that I wouldn't be able to reach that. Well, that's totally a 30-bit integer. Yeah, I know a lot of people who use, like, they keep a Git repo for, like, their bash configs and their all sorts of things. Quite a few people I know actually do that. They keep a dot file, like, they call it a dot files repo. And it's, you know, the bash RC, GDB RC, and things like that, which works reasonably well. It's just one more configuration step, and the default stuff tends to work well enough that I don't care too much. So, works for me. This is interesting. So it turns out that it looks like we can get away with doing it the way that I wanted to do it. It's a little sketchy, but it looks like we can still do it. Because we don't need... We need it to be a negative value, but we don't necessarily need it to be a... But we... Sorry. We can have negative values. In fact, we can have negative values that are this big. We just can't have really, really big ones. So, if offset, what am I doing here? Is less than, I'm completely blanking on what I'm doing here. If it is less than 0 minus 2 to 31, return nothing. That looks good. That worked fine. Get pointer. So get pointer is going to return a valid pointer to us. So n is equal to np array abcd. Base adder is equal to n.ctypes.data. Return base adder. So heap adder is equal to get pointer. So we're doing this so we know we have a valid pointer. Heap adder. Look at that. Hex that thing. So this is working a little bit. The problem is that we need to know the address of this object. So I think what we need to do is we need to actually define this up here like that. And we're going to do, so what we want to do is we want to align this, and then we're going to walk backwards until we find that header. So we know what the base of our thing is, because for whatever reason, our, what am I doing here? USR bin Python 2.7. Our why am I blanking here? Oh, I don't have checksec set up on the system yet, do I? Okay, let's go grab that real quick. Checksec. I'm going to take the first link off Google. I'm going to run it because I automatically trust everything. cd mkdir tools, cd tools, git clone of that thing. Do I not have? That's interesting. Apparently I had networking into the VM, but not out of the VM, which is a little odd. Oh, come on. Which Python? And of course I need to pass in the -- file argument. So it is full Railroad and Pi is enabled, unlike the system that, what was that? Why did that take longer to run? I don't know. I don't care that much. Unlike the version that the article is about, this version is compiled with Pi, which means we can't just assume that we're operating a certain address. What we can do is we can walk backwards until we hit the signature at the start of it. So aligned is equal to heap adder and OX 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Trying to think. I am completely blanking here. I believe that is correct. We want to get rid of the last few bytes. Print hex aligned, print hex heap adder. Because what we want here, yeah, that looks like what I want. And while one, for I in X range OX, sure. Minus OX 1000 times I. Look at that. Especially because that right there looks like the magic we're looking for. Kind of. No, it doesn't. I'm lying. Print hex address. I mean, that makes sense, right? iproc mappings. Five 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 55 A78. That looks like it should be readable, right? It says it's right there. Oh, am I being dumb again? I think I'm being dumb again. Yeah, no, there's totally a jump there. It's a good idea. But no, those are totally separate. That actually gets us most of the way there, right? So, what does this tell us? This tells us that we can walk backwards. Actually, while we're at it, let's switch to 64. Q, rerun it. Okay. So as we're walking backwards, I would expect to see someplace in here stuff that looks kind of like some pointers. This doesn't look a lot like pointers, though. Because I would kind of expect to see eventually that we hit our got entries, but I don't know why we're not seeing those. It's unfortunate. I mean, that looks like a decent one. Dope. GX. Oh, that doesn't look good at all. So we can get to the data section reasonably well. Like, we can get to the writable stuff here. Can't quite get to the stuff that I actually want to get to, because the stuff I want to get to is elsewhere. I mean, we're getting to the stuff I want to get to. I just don't know where exactly it is. We always hard code this. I don't like that as an answer, but it would work. Well, let's see here. So one of the options, what I wanted to have here is I wanted to make this exploit as generic as possible. I wanted to work across versions of Python, across versions of NumPy as much as I possibly can get away with. So if I hard code an offset to entries, that's not going to work very well. It's going to end up forcing us to specific versions, potentially use like specific compile flags even. And if I can avoid that, I'd very much like to avoid it. Well, I mean, maybe I'm just being dumb here. Sudo pip install pwn tools. What we're going to do here, as this installs, is I'm going to use the magic that is dynelf, because really it's magic. while this is installing, we're gonna come over here. So what is dynelf? Dynelf is some magic out of Pwn tools that you basically give it a function, which can read memory, and a pointer that isn't going to segfault, and then you can look up functions. It's just magic. Like, really, it's pretty magic. They're doing basically the same thing that I was trying to do, but I was trying to, do it the shitty fast way, whereas the people who wrote Pwn tools actually looked into how to do it kind of the right way. So we're going to steal that code. Well, we're not going to steal it. We're going to import their library and use it. Like all good exploits, we include Pwn tools because why not? Oh no! We have an exception. Oh. We're installing it as root now. No, sorry. You guys don't get to see that. We're installing it as root now. But yeah, so if you've never used it before, like dynelf is really interesting because it solves a lot of problems for CTF stuff. However, a lot of the time it fails on CTF stuff. Because of how it works, it takes advantage of a ton of different reads into the binary. So I have some sort of a read primitive. So dynelf, you pass it in as a function. It's going to try and read stuff out of it. And it should just work. The catch is that it takes a long time. Well, it takes a lot of reads. And if you're going over a network connection, that can be way longer than the response time. Like I've had it take, several hundred different primitive usages, which in the case of something, if I'm round tripping from my house to China, that takes a long time and I just can't do that. I will definitely time out before that works. So I'm going to do d is equal to dynelf read comma heap adder. I actually don't think this is going to work now that I say that. Because we have a heap address, I think this is actually going to cause us to fault. None comma libc. But we'll see. Oop. Print hex that thing. It's kind of funny that I'm actually using this like inside of like I'm using this inside of the thing that I'm trying to land. That's what I was concerned about. Iteration over a 0D array. No elf provided. Leaking is much faster if you have a copy of the elf being leaked. Yeah, I know it is. I was thinking this should work. Oh. Print hex ret. Yeah, that's what's going on, I think. P64 ret. I think that works better, doesn't it? Integer out of range for Q. What magic is this? Oh no, we want to be over here. Oh. It's unfortunate that it's giving us negative numbers. I'm not sure if there's an easier way to do it than what I'm doing here. 2 to the 64, ret and equals 2 to the 64 minus 1. Okay. Add output type code O could not be coerced to provide an input parameter type code L. What? What crazy talk is that? Okay. Well, that's unfortunate. Yeah, this is what I was concerned about. It would be nice to have some better indicator of the console focus. Yeah, I need to come up with a better way to do it, because it's actually, if you've noticed, it screwed me up a few times here that I can't quite tell where I'm looking at. I should figure out a good way to, like, get a decent border around whichever one I'm currently focused on. Because, like, right now, I don't even have a cursor on the one that I'm on. I'm not sure why that is. For some reason, I'm eating the cursor, and I haven't figured out why. I suspect it's because I'm using the bash on Windows stuff, and it's not playing quite well with something, and it's eating my cursor. I should have a nice little cursor going there and going, oh yes, I'm on this terminal. But so I can't just use dynelf because I don't have I have a pointer into the heap, not into the binary. And having a pointer into the heap and not into the binary doesn't do me any good. So what else can I do? This is actually really awkward. I'm not sure. No, I'm not doing it all in the WSL. So I'm using WSL as basically using it like putty to SSH into. So the current setup I have here, I can actually show it off a little bit here. Is I am using Hyper-V with a Ubuntu 1704 VM on Windows 10, and then the terminal I'm using here is I'm SSHing into that VM, and I found that to be one of the better ways to do all the things I want to be able to do on a computer. Basically, I want to be able to, one, run Linux VMs very quickly. And unfortunately, VMware's caused a lot of problems with me in the past. Like, if you remember the earlier streams, I was running into all those issues with it lagging out and things like that. Hyper-V, none of those issues. It seems rock solid, very high performance. So Hyper-V, do recommend as a VM platform if you're on Windows. And then I'm using WSL to get into it because this right here, their like virtual machine console thing, not impressed at all with it. I've not been pleased with it. It doesn't work very well. I basically use it to get the IP address that I can SSH in, and that's it. That's the environment that I'm currently using. It also makes it easy to line up and use, like when I want to go out to EC2 or something like that, it's super easy to transfer over to it, and it just works. and I'm pretty happy with it. The one caveat that I will add here is that the networking is by VMware. Hyper-V doesn't come with a NAT for their networking. It's bridged only. I think that's right. Yeah, it's bridged only. And basically, if you are ever doing anything wirelessly, good luck. It's not going to work. So I install VMware. I use just their network stuff, and everything else is in Hyper-V. That's the way it's set up right now. And I'm pretty happy with it. Getting the colors was actually the colors here was actually the hardest part. Their default colors, this blue color is completely unreadable. Or this blue color, one of the two. You literally cannot read it on the screen, and it's dumb. But there's some registry edits you make, and the colors work. So that's the current setup. So back to trying to exploit this. It's tricky. It is very tricky. Wait a minute. So where are we? This one. Print hex ID n. Read ox4141414. Plus heap adder plus that. Yeah, there we go. Sig v. And I want to copy this thing. That's right. I can take advantage of that. So instead of walking down, I can walk up. So I know that under certain situations, ID is going to return something out of this block of memory. That block of memory is an immapped region. So, and that looks contiguous, what I can do is, I think it's a safe assumption that we can add 40,000 hex to it and just use that as the dynelf thing, and maybe that just works. So where were we? I want to do d is equal to dynelf read, comma, ID n plus ox 40,000, right? That's how big that thing is. D dot lookup none libc. Print hex of that thing. Really? That shouldn't happen. What's our signed integer is greater than maximum? Oh, we're actually much more limited than I thought we were. We can't even hit that stuff? That's not going to work well. This got awkward fast. I was hoping this was going to be really easy. But it turns out it looks like we're limited to being within a 32-bit int, signed 32-bit int of our heap address. That's unfortunate indeed. Not sure what the best way to take advantage of this is. Like, we can definitely spray things all over the heap. That doesn't necessarily do much for us. We want to be a little bit smarter than that. So what can we do here? Looks like my idea of a generic exploit is not going to work very well, because I think we're going to have to tie everything together pretty closely. Because I think what we're going to have to do here is some heap metadata tomfoolery, which isn't quite where I wanted to be here. I wanted this to be super simple and just be like, oh, look at this, we're done. Bam! Look at how awesome it is. But looks like that is not the happenings. Tisk, tisk, tisk. How are we getting that other error then? Like, we were definitely getting something about it rolling over. But I guess if we were doing really big numbers, that would happen. Read heap adder plus 2 to 32 to 32. U. -1. Yeah, that's pretty gross. This primitive is actually much more constrained than I was hoping it was. I was hoping it would just be, here's an address, give me some values out of it, like give me some bytes out of it. But it would appear that is not the case, that I am going to have to actually do some real work here. By real work, I mean, so we totally can read and write values out of the heap, but it is going to be a relatively constrained read and write. It has to be within, well, so one thing we can do here is we can say, you know what, 64-bit Python is hard. We just switch to 32-bit Python, this would just work. Like, we would have no problems at all doing this on 32-bit Python. That's less interesting. We might as well land it on the 64-bit Python because it's still very doable on the 64-bit Python. It's just a little trickier to do. So. One thing I find interesting, and that I'm not quite sure about, is we appear to just be trusting that offset field. Not sure how useful that is. So let's go back over here for a second. So this is the exploit from the article, which uses yeah, they're huh. Let's think about this for a minute. We could, well, let's actually go up here and read some of this Python stuff. So what does a Python object look like in memory? A string type has all of this stuff. Has a basic size, item size, a destructor. That's interesting. What am I doing here? I'm coming over here. I want to do that print A is equal to A, B, C, D, E, F, print hex ID A. Okay. Oh, this thing, right? Okay. That definitely looks like what I'm expecting to see here. And if I do I actually have this type? Key type, pi string type. Do have that? Okay. So if I do pi string type star, that thing. We want to print that out. Really? How do I do this properly? I thought I could do that pretty simply. Oh, I can just access it that way. So I want to do print pi string type star ox that. Really? Oh, it is actually a pi string object. There we go. And I actually want to see what the tpd alloc function looks like. Maybe I have to dereference the address. That may very well be true. I really wish I had a cursor, and I don't know why I've lost my cursor. Pi string object star this thing. So that is ref count, the strict type object, the size, the object size, then the name is a const char star. That doesn't seem right. That does not look like a const char star to me. Like, that looks like a ref count. I'll buy that that's a ref count. That looks like a structure to a pointer. I will buy that that is a size, especially considering that it's a 6-character string. Oh, maybe I'm being dumb here. I'm, in fact, being dumb, it looks like, because our version appears to be different than their version. So where were we? We have this. This should no, that doesn't look right, right? Pi string type. So what I'm hoping for is that there should be like a list of functions in this thing, right? I don't actually see a list of functions there. Unless, is this a list of, is this, like, I should see a destructor and a constructor. Oh, that does not look like a function pointer. 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 That looks like it might be a function pointer, but I don't think it's a function pointer. So where are these magic function pointers that are supposed to be there? I do not like this. That looks like it might be a function pointer. Nope. Nope, that's not a function pointer. Sorry about this. I was hoping this would be a little bit more straightforward than it's turning out to be. Because unfortunately, this is not giving me what I want. Print that, and then our object is this thing. So we have an object type. An object type, we have an object hash, state, and an sval. I guess all that other stuff doesn't actually work that way. Oh, right, because I'm printing out the wrong thing, because I'm being dumb, aren't I? Yeah, I'm printing out the string type, which is not at all what we want. Okay, that makes sense. Huh. So we could change the type, which is interesting. But I don't know what that does for us. So I'm thinking about this, right? So we're going to have this offset we can write to. And some of the tricks we could play is we could change a object from one type to another and see if we can do anything useful from there. But I don't know if that's immediately going to be useful. It would eventually get us what we want, but not immediately. Oh, is that what that is? Okay, that makes sense. So print star string type star that thing. No, can I not do that? Greetings from Poland. Hello, Camille. Camille? Something like that. It is very late for you in Poland, is it not? Like, it's like 1 or 2 in the morning, isn't it? So if we print out this thing, x/20gx at this. Yeah, it's 2:30 in the morning in Poland. 2:30 in the morning in Poland, and you're watching me stumble around and try and get Python to do things like I want it to do things. Okay. Jeez, that is very early in the morning. So, this thing, that's a ref count, that's a type, that's a, no, what am I looking at? I want, yeah, so I should eventually, like this thing right here? That is a function pointer. This looks like a function pointer. I'll buy that that's a function pointer. Oh no, this is going to get cut off. 820. Less convinced that's a function pointer, but that kind of looks like a function pointer. So what we could do here is we could try and abuse the crap out of that. So, where's this address? Proc mappings. That's 555A. So 555. So this should be a writable region of memory. So if we could figure out how to get a pointer to the Python object type, we could like remap how, like what function is called to print it. That may be the path forward here. We can remap all of this stuff and mess with that. That's going to take some work though. So before we dive into that, I'm going to go take a few minute break. I'm going to get myself another drink, and I should be back in, say about 5 minutes. So I will see you all in a few minutes, and I will be back. While I'm at it, you guys can stare at what this object looks like. So I'll be right back, everybody. Bye. Okay, and we're back. So, let's see here. Where were we? So, trying to think here. So we were saying that we can take advantage of some of these objects in the heap because some of them have function pointers that we can control. And that gets us a big chunk of the way towards where we want to be. We just have to actually get things arranged in such a way that it's going to be useful to us. Can you actually hear me okay here? The sound quality sounds a little bit different on my end right now. I'm not sure if I've positioned myself differently or what. Hopefully everything sounds right. But yeah. So I think the first step here. So x/20gx $RSI minus this was much easier when I actually understood where it was. 2, 3, 4. Okay. I mean, as long as you can hear me properly, that's all that matters, right? 20gx $RSI minus OX41414141. Oh, sorry. So, what I'm hoping for here is that as part of the standard process of creating this stuff, we're actually going to have a object immediately before us that's also useful. Let's see if we're that lucky. So nothing is jumping out at me immediately here. However, so this right here is the heap allocation for the string buffer we have here, the ABCD. Immediately before that is this. I don't know what this is. This is another buffer of the same size. My guess is that they're allocating just this part, and that this chunk is just uninitialized. If we keep walking backwards here, this is something. This looks interesting. What is this? That actually looks relatively similar to what we were hoping to see. Like, I'm curious how consistent that is. I would assume it's going to be relatively consistent. Although, if there's a whole bunch of, as long as they're relatively close to the start of this, I'm not sure how much I care that this is going to get, like, the more we do this, the more fragile this is going to get. But I'm not sure how much I care. I'm kind of okay with it at this point, us having an exploit that works, but won't work if you've been doing a whole bunch of Python stuff previously. So what were we saying here? This pointer, the AB9618, is at minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if we do, we want to print hex read heap adder minus OX10 times 8. Yes, rerun it. And we're going to do a print dash times 20, so we actually know what we're looking at. Okay. So this thing right here, so this is the ID of A. This is the pointer we're reading from. This is the value we're reading from. That's how that works. Oh, wait. Hex argument can't be converted to hex. What? What on earth is going on here? Oh, right, because this is not something we should be hexing. This is reppering, because it now returns an actual thing. So we wanted to actually do hex U64, that thing. Much better. So this that looks kind of promising. Right? So what I'm hoping for here is if we blow away, that looks like a function pointer. We blow away all of this stuff though. And then we let it free, maybe we get PC control. Give it a try. So we have this, which is the arbitrary-ish write. Arbitrary-ish read. So base adder is equal to n.ctypes.data. Yank this. So writing a string is going to be a little bit difficult. Buff is equal to p64 string dot ljust. I think that's what I want. I never remember the right order for this. Right, Python from pwn import star. P64 a dot ljust 8 comma slash x00 that. Cannot convert to integer. That looks right-ish. Right, I'm being dumb. I'm being very dumb here, aren't I? What am I doing? If len string plus equals slash x00 times len string minus 8 minus. We're just gonna do it this way. When string is less than or equal to 8. Okay, so that's not entirely clean, but it'll totally work, so I'm not too concerned. So then we want to do n.setField u64 string np.int64 and then offset. I believe that should just work. That should let us write an arbitrary value to an arbitrary thing in memory. I mean, hopefully that's how that works. Let's verify that. So a times 8, or that's the thing that we're doing. The address is going to be heap adder plus ox41414141. Right, that looks good. Sig v. we are trying to write racks to RDI. RDI minus OX41414141 is in fact what we wanted to have. So good. This gives us a arbitrary-ish read and an arbitrary-ish write. It's relative, and we're constrained to plus or minus a signed 32-bit integer, which is why it's an ish read and write as opposed to a real arbitrary read and write. So we have that. The next stage is this right here. Geez. This thing right here is a like object def is that. And right, that's giving us this thing. And I'm going to say we're just going to blow all of this away, which is probably pretty dangerous, but I'm okay with it. So for I in x range 20, write the first argument is the address. So object def plus I times 8, and then chr OX41 plus I times 8. Next it normally. Interesting. Read heap adder plus OX41414141. We definitely blew all that away. It would appear that it doesn't matter, though. Oop. Print So whatever this thing is, it's not actually being used. That's unfortunate. So what is this thing? Right, and we're actually ending up right. We're definitely in the read, like I expect us to be. Well, what if we just keep going? Seg faulting intentionally. This is the YOLO. That's what I wanted to see. So we have indeed successfully managed to cause a seg fault with a controlled PC. Which is good. Is it reliable? So if I come over here, here, ulimit-c unlimited, Python split, bing gdb, ir, gdb, gdb, which Python, cool. That's unfortunate. Oh, RM core. Let's do this again. That looks pretty predictable to me. I'm happy enough with that. So, what are we actually doing here? So we have x/x, rbx. That's nothing super useful. rcx, rsi. That might be useful. Actually, let's go back to this one. 20gx, rsi. That doesn't look super promising. So the reason I'm saying super promising is because ideally one of these registers looks pretty good, and that we're going to be able to start just a pretty standard ROP chain off of this. But ooh, I can work with this. So R8 points at the data we write. Like, this is definitely a thing we can overwrite. I'm pretty okay with this. Hmm. And what did we say our registers looked like? For 12, doesn't look useful. Or 13, not super useful. Or 14, not super useful. And we said RIP is jumping to R9. Okay. So this works reasonably well. Like, we're gonna be able to write into this, which works fine. So we're dying here immediately after writing the 62, because we're not getting to the 63. Which means what does this mean? It means we can't do some of the stupid things that might be useful. Also means we might run into some other problems in a second here. Sorry, thinking about this for a minute, because the more we think about this before we start writing a whole bunch of code, the better off we're going to be in the long run. One of the worst things we can do here is write a ton of code, have it break on us, and be completely lost. So let's go get us some wrap gadget. So wrap gadget. So we are grabbing ROP gadget here. That's a tool by Jonathan Salwan. It is pretty great for gadget finding, and I also don't have it on this machine yet. CD ROP gadget. Looks good. Yeah, we're going to install this everywhere. Python. Oh, you guys can't see this again. Oops. Sudo python install. My password. Okay. So if we come back over here, projects, Python, exploit. Yep, I switched back. Got it this time. Not quite awful. ROP gadget. Oh no, we failed to load capstone, didn't we? Shit. Shit. This is the worst. What is wrapper? Pip install wrapper. Never used wrapper. I've only ever used wrap-gadget. Permission denied. Sudo bang bang. So we're gonna learn a new tool. This is where you go, haha, I've stolen your computer because I've got, this is my code and it's the worst. -f. Which Python? Eh? Oh. Crap. This is gross. Sudo pip uninstall capstone. No. Yeah, I actually really like wrap-gadget, although I've never used wrapper, so we now have both. Wrap-gadget. I hate capstone so much because this always happens with capstone. For all of the benefits of using capstone, in that it kind of just works, sudo pip remove wrap-gadget. Oh. Like, I have a cursor again. I don't understand how computers work. Wrapper. Pip install wrapper. Pip install wrapper. Pip install wrapper. Wrapper. Oh, capstone. Oh, capstone. Okay. Oh, it's because No, it should work. Like, pip remove capstone. Pip uninstall capstone. Yes. Maybe this works? I don't know. Nope. Sudo pip install wrapper. There we go. Okay, so the problem is that pip is not giving me the version that I actually want. Projects Python exploit, and I'm going to do wrapper-f /usr bin python 2.7. This is Ropper. I've never used Ropper before. Let's see how it works. That's always the best time to learn a new tool, right? When I'm doing it live in front of ones of people. It's always the best time to try something new, right? I believe the common way to refer to this is "fuck it, we'll do it live." Removing double gadgets. Ooh, fancy. So it is Ropper. While we're reading here. Oh my. Oh my, that is quite a bit of text. So much text. Oh my. When is this going to stop? Yeah, it's pretty common, I think, for most of the people watching to be quiet. I think it's true of a lot of streams. Oh my, this is many, many gadgets. I mean, the good news here is that we have so many gadgets. So the way that I usually do things is I actually, well, let's see here. What options do you have? Hmm. Okay. Hmm. That's interesting that it will handle some of the CFG stuff too. Is there an example of using the dash dash chain? So one of the things that I like about doing, oh, that is fancy. So one of the things I like about using ROP gadget is that you can have it generate a ROP chain, but it looks like this works quite well. So if I do that, dash dash chain, exec ve cmd is equal to /bin/sh. Go! Because auto-generating ROP chains is so much easier than trying to do it manually. Like, if I can get a tool to auto-generate ROP gadgets, I will do that all day, every day. Because it's just so much more convenient. And ROP gadget has some basic functionality to do that. This looks much cleaner, though. You look at that. So, what on earth am I looking at here? So, we set up an image base. We then rebase it. Okay, I will buy that this is a thing. Man, that is actually much more efficient too, because the way that ROP Gadget does it is it will actually do like a whole bunch of inks to get to it, as opposed to this pop RAX. Like, that is quite efficient. I like this a lot. What other options do I have here? Sorry, I am getting a little bit derailed because now I found a new tool. That's exciting. And let's move this over a little bit so people can read with me. Wow, this is quite detailed. Wow. I want to see what... Tell me about this chain stuff. I want to read about this chain stuff. You know what? That's a little bit too much work. But this should just work, right? So if I do... Oh, wrong thing. Oh no, that's not what I wanted at all. I've broken everything, haven't I? That can go away. Let's go back over here. So I want escape. We want to yank all of this. Never worked for CTF challenges. Well, this looks plausible. Like, assuming that all of this is correct, it looks like it should work. We want to dump that. So we're gonna need to figure out what the image base is, which we don't currently have. So what do we know? We know that sorry, I'm kind of blanking here for a second. If we pull out the value that is currently there, so we said that at 62 is where we are. So f pointer is equal to read object def plus ox62 times 8.
Sorry, I'm not sure.
Seriously? What on earth did I say that sounded like Alexa? Of course, now it's going to trigger. Speaking of which, I don't know if any of you saw the WWDC stuff. It sounds like Apple is getting in on the Home Assistant game too. They decided they would not be left out. The Home Base, I think it's called. Looks interesting. So anyway, so we have an f pointer. Print. We're going to do a U64 of that. Print hex f pointer. Yep. Okay. So this is definitely, yeah, that's definitely in that section. So what we can do here is we know that this, like that function pointer, is going to be in there. And let me think about this for a second. So what we're currently doing, like the ROP chain we're writing here, is specific enough that I think I'm okay with this only working on the current version of Python we're using. I don't like it exactly, but it works. I can live with that. So image base is going to be f pointer minus ox162 cao. And when we're done with this, we can, like, if all of this works, we can go back and fix some of this stuff in a minute, though. So we have this to write our ROP chain. We're going to get rid of... We're going to comment this out rather than getting rid of it right away. So we've generated a ROP chain here. We've rebased it. Then we want to do write object def plus I times ox61. So this is the thing immediately before the function pointer we control. We're going to write, and the value we're going to write is this rebase 0. We're going to do yank to that. There we go. And the reason we're doing this is, if you remember, we had something. So R8. Well, we also need to find a gadget which moves. Basically, does a move RSP R8 return. But that's. So R8 points at data we control. So we need to find a gadget that takes care of that. Let's actually fix that before we do anything crazy here. OX, you know what, U64, A times 8. And we're going to do a write. This is 62 and 62, 63. This is going to be B. It's going to be C. Right? Oh no. Why are we failing? Why are we failing? So we're at line 59. What is going on here? So the problem here is that both this script and Pwn tools are, or not. Maybe I'm talking crazy. There we go. Hacker. There we go. I is not defined. Times 8. Times 8. Times 8. Int type has no len. Okay, so if I'm correct here, we should see 5gx at R8 that we have basically exactly what I expect to see here, that the stuff is laid out how we want it to be laid out. But let's verify that we can actually do this properly first. So we're going to comment. Why is that not commenting? Okay. Oh. For I in x range len rop over 8. I plus that times 8. And we want rop I times 8 to I plus 1 times 8. Like that. Valid syntax. Bad argument to internal function. What on earth are we running into here? Print hex address, comma, repr string. Oh, oops. So why did my... You know, it's like my cursor came back, and I'm not quite sure why my cursor came back. So we wrote our binsh, that worked okay. Then the next thing we're trying to write is something that it doesn't like. Not sure why it doesn't like that. What is going on? Bad argument to internal function. Hmm. Oh, so it's definitely in the binsh. Oh. Oh. 1, 2, 3, 4, 5, 6, 7. No. Hmm. Why is it failing? Oh, are we like bashing something we actually care about here? That's kind of amusing if that's the case. Um. Hmm. Does this just work? That does just work. Awesome. Okay. So, whatever we're doing here is pretty gross. Do we still have... Yeah, we still have this. So we have this, and supposedly I can do -- console. I can search for stuff. Okay? Okay, so I can do a search percent move RSP. Hmm. Interesting. Search exchange RSP. That's not looking so good. Pop RSP. That's better. Can we have a push R9 pop RSP? How do I actually use this search? Are there tricks to using it? Is there a wiki? No. Here, I'll make it so you can actually see what I'm doing here. So this is Ropper. Does the wiki have anything? There's nothing in there. Okay. There's a project page down here. What is on the project page? Ropper is inspired by RopGadget, but should be more than a gadgets finder. It is possible to show information about a binary. Okay. Hmm. So I want to find here. So I want to find a push R9. Ooh, the percent is a wild card. Okay. Push R9 percent pop RSP percent. Nothing. Okay. Okay. That, yeah. Did not realize that percent was a wild card like that. I like this highlighting too. That makes it super easy to read. Yeah. Hmm. Oh, sorry. Yep. Curious if there's a good way to automate that. Although it might be a little tricky to try and automate where my focus is. I just need to get better at remembering to do it. So these are the ones that have a pop RSP. What about a search exchange RSP? There were none of these, right? Exchange. Can you do r.x? No. Hmm. So that moves R9 into Rex, but that doesn't help me much. Ideally I want an R8, right? Like, the ideal gadget here is a move RSP R8, but that's not going to be a gadget. Try underscore. Call R underscore X. Yeah. Oh. I mean, that's kind of doing what I want, but. Hmm. So where were we again? So when we're here, and then we want to do a write object def plus ox62 times 8 of b times 8. Okay. So we're doing a jump R9. Looks good. And what do we control? That does not look promising. That does not look promising. Doesn't look promising. What does look kind of promising is that. But it means we have to do something with R8. And R8 isn't particularly gadget friendly. Right? So this is where we were, right? Search R8. Search percent R8 percent. I mean, I guess there's quite a few. What kind of a gadget is a ret starts with a ret? It seems odd to tell me that that's a thing. Um, You help stack pivot. Prints out all stack pivot gadgets. Okay. Well, that's convenient. Okay. There are many stack pivot gadgets, and of course, I can't even print all of them out here. Can I stack these? Help search. Quality of the gadget. The better the quality, the less instructions there are between the found instruction and the ret. Interesting. So a question mark is a single character. Okay. That's really helpful. Like, this is... So, thank you, Disconnected. This is super interesting, and I like it a lot. This appears to add a lot of the stuff that I wish that Prop Gadget had. And it doesn't. So this is quite useful. Okay, can I give this arguments? I can't give this arguments. I'm going to quit. Stack pivot. No, it's dash pivot. Into pivots. Hopefully this works. I'll just dump it to a file and I can read the file, because unfortunately 1500 gadgets is more than my scrollback can handle, and I don't feel like reconfiguring it. Yes, Kitty? Do-do-do. Pivots. Oh, it's colorized. Oops, other way around. R8 pivots. Well, that's unfortunate. So that's the only time R8 is used in a pivot, what it thinks is a pivot. Which means we're going to have to get, we're going to have to think harder. So, what? What is it, RSP already? Like, are we lucky enough that, like, one of these is pointing at something useful? x/gx $RSP star $RSP. Just no, that doesn't work. I thought there was a way to do that. None of those look exciting though. I mean, we can write to some of these, but is that really where we want to go with this? So one of the options here that will work, right? So is we can take advantage of, well, let's actually make sure that we can do this first before I talk too much about it. We can't. Look at that. What I was going to say is RCX is one of the places we could write to. Like, we can totally write to that. So we could, if we could pivot from RCX into RSP, we could just write to that and bash things around. But it looks like that is not so convenient. Other options. So we said 20GX RSP. What is at this thing? This is code? Yeah, that's totally code. This, however, is not code. So what we can do here, I'm not thrilled that I'm doing this, but it should work, is we can find a pop, 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 pop ret gadget. So back up here. Search %pop 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 %ret. So any of these gadgets should work. What that's going to do, we're going to take this right here, and instead of b times that, we're going to do rebase 0 that. Oop. Rebay. No. Okay. That is what I expect to see, right? We have completed that ret, and we are now pointing at the thing that I was expecting to point at. Which is good. Well, it's not good, but it gets us basically where I want to be. So now we can write our gadgets. Oh, no, we're trying to call this. I don't want to call this. Do I want to call this? I don't want to call this. No, I need to pop RSP. Are any of these finishing with a pop RSP? Meaning, I can put a gadget there. No, I can't. Can I put a gadget there? I can't put code there. We're trying to ret to that. We don't want to ret to that. So we've got some jumps here. I mean, this right here looks kind of promising, right? So we've popped a bunch, and at this point we would control REX. You know, as we go farther and farther down this, we're getting farther and farther away from this being something portable. Like, using some of these gadgets means that this will probably not work on many systems. We're getting close to the it works on my system, and that's going to be about it. Which, I mean, I guess that's okay. It's a little disappointing because I was hoping we'd be able to make this into something that is like super robust and just works all the time on any system you throw it at. But I can live with this. So when we did this pop, RSP now points at something we can write to. So search pop or %pop rsp%ret. Ooh, there are some of those, and we can do a +1. How do I do that? Ooh. So if we do it like that, that gives us another gadget. So we're going to take this right here. Oh no, what just happened? Oh, that thing. And we said we wanted this one too. Right, so, wait, no, crap, that doesn't work. Because we don't control that. What is an RAX right now? That doesn't work at all. Oh. So we've got all these pops. But reading to that last one isn't going to work. None of those jumps are going to work either. Unless they just happen to already line up to something that would work. Which seems unlikely at best. We don't control the values going into them. I was kind of hoping this would work much easier than this. But it's not. I'm trying to think of what we can do here that's going to be useful. So RCX is code, right? Doesn't help us. Is that code? Yeah, that's code. R8 points to stuff we control. But we can't do anything useful with it. Can we? Like, none of those pivots looked useful. Projects, Python, exploit, vim, pivots. Wrapper-f/usr bin python 2.7 stack pivot -h. I want no color. No color. No. Okay, let's give this a try. You're on your 4th? That's the way to go. Hopefully we get some good progress before you run out of beer. Okay. It would help if I piped that into pivots so I can actually read it. So what we may be able to do is take advantage of some of these, like, weird rets, but I don't like you doing that. So the ret with an argument is going to pop that many values off the stack, which might work in some situations, but I don't like using it because they're kind of difficult to maintain. Not that that matters that much, but ugh. And I guess I have all the options for that, right? If only EAX pointed at our data. Like, that would make things so much easier for us. I mean, ideally there's a simple gadget that we can use here that's going to take R8 and dump it into RSP, but it doesn't look like we're that lucky. So, what are some of these other objects? What does an RBX look like? So, like, we might be able to dereference some of this stuff and make use of it. I'm not sure that's any more useful, right? Like, unless there's a pop power RSP. Kind of surprised. Search percent pop RSP. There's plenty of pop RSPs. Why don't they consider those gadgets? Also, what am I thinking? So, pop RSP only works here if we've already pivoted once. So we need to pivot to RBX and then do it. It might work. So, like, is there a, what am I searching for? Search percent exchange EBX ESP percent pop. I mean, are there anything like that? So there are some of those, which are going to immediately segfault, which are exciting and are unuseful. Awesome. What about a move RSP RBX? None of those. RSI? Search push RBX pop RSP. Ooh. Close, but not quite what we need. We're getting closer though, right? So that's a little promising. What about a RSI? If there was one more pop in between those, we could work with it. Because, so, with that second gadget there, we would immediately segfault then on 1, the address 1, which is not what we want at all. Now we can do some wacky shit and, like, try and make it, because it's probably a number of references for some object. But we don't want to mess with that too much. Like, that's messy and gross, and I don't want to do it. I thought I should be able to. I could do that, can't I? Where'd my cursor go? Yeah, not sure why my cursor keeps disappearing. Not happy about that. Also not happy that I'm not making better progress in this. It seems weird. We currently have PC, but we can't do anything with it. I mean, we could always do the CTF trick and use the bespoke gadget to pop us a shell. But I'd like to do better than that. Would like to do better than that. Right now we get PC once, and only once. R8 points to data we control. But there aren't a ton of these gadgets that use R8, %, R8%. I mean, I guess there's all of these gadgets that we could search through. Oh yes, all these gadgets with a weight in them. That's super exciting. Search %, move R8%. I'm going to do a /1. So none of those are super exciting, but like, I mean, ideally we would come up with a I want to do that. I like this feature. So I mean, like, ideally we're going to do a move RDI R8 something that uses RDI now, but nothing is jumping out at me immediately. Ooh. Oh. This was exciting for a second. And then I realized that R8 plus 8 is the gadget we have. So if it was anything but plus 8, we'd be in a lot better shape here. There's several of these where we move R8 into. Hello, Matthew. Or move R8 into something. But I don't see any. None of these are jumping out at me in ways where we move it into. This is a little interesting, and then it loops. Right? So, man, if that was anything but plus 8, we'd be in good shape. Or alternatively, if instead of moving it into RDI, it was moving it into any of the other registers we can call an offset from. Okay. So, unfortunately, Matthew, we've been at this for about 3.5 hours now, and I think this is about the time to call it an evening. So, sorry for calling it as soon as you show up, but at this point, I think it's about time to take a break here. We currently have PC control in at least one method. what may be the answer is we need to go back and rework this. So we're currently using a read and write to the first thing that got us PC control, and the register state at that point isn't exactly conducive to useful exploitation. So it might be worth going back and exploring more other ways to get PC control, because right now we're writing into the heap and we're kind of just taking advantage of the stuff that's there. So we might need to go back and reinvestigate other things on in that region that we can write to and see if maybe we can get something that's a little bit more convenient. Or we can keep investigating the ROP gadgets. I'm not sure which one's actually going to prove more fruitful, because both of them are perfectly valid. And I think a lot of the time, if I had infinite time here, I'd go down both paths. I definitely keep looking at the different ROP gadgets we have and really dig into, like, are there any interesting gadgets that use our stuff? But I guess we can come over here real quick. And we did this, and we did this. So we weren't, and we got rip, which, that's definitely progress. It's not quite the progress I would have liked to have, because I would have liked to have had this entire exploit working. But we're getting decent progress. So I think it's about everything. I guess the only thing left to do is to remind any of the viewers, if you've enjoyed watching this, please subscribe to the channel. We're getting close to the 1,000 person cutoff, or 1,000 subscriber cutoff, which YouTube turns on some bonus features at that point, which would be nice to have. Also, feel free to follow me on Twitter. I tend to do status updates, and I like to talk about the streams beforehand there a lot. I also, so on Twitter, I usually talk about the specifics of what we're going to do. Whereas on Mastodon, which is the poning.social link there, I like to talk about ideas of future things to do. So I've been talking about some of the future series that I'd like to do. For one, I'm considering, after we finish the Python series, taking a break from exploitation for a little bit and doing some shellcoding and writing custom shellcode and odd formats. But we'll see. But yeah, I like to talk about on Twitter what we are going to do because of the short constraints, and on Mastodon some of the ideas, because I can explain a little bit more what I mean by things. So if you're interested in that, feel free to follow me on any of those services or subscribe on YouTube. Both of those would be appreciated. So thanks everybody for coming out tonight. We got good progress, and we had a nice long stream tonight, which was exciting. So other channels to watch, I would definitely watch, so actually, I will turn this on for a second here. I believe that if we come in here, come on. And of course you can't see that. So basically any of these here, I would definitely recommend. So Ginvale stuff is amazing. Live Overflow stuff is so Ginvale does a lot of live streaming. So kind of similar format to this, where we're discussing some topic, going into it. Live Overflow doesn't do much in the way of live streaming. I don't think he does any at all. Instead, they're pre-recorded videos, so they're much more concise. They stay on topic. The malware analysis is good. I know Ginvale was talking about those. And, oh, I am missing him off here. I would recommend the Gamozo Lab stuff, if you haven't watched those, although he very rarely streams. So he just did a stream over the weekend on this AVX stuff. Basically, he is trying to highly optimize his emulator to do some interesting stuff. If you're interested in very high-end fuzzing, I would definitely recommend taking a look at the Gamozo Lab stuff. Would definitely recommend him. Other than that, I don't really know. I would, if you have good recommendations, I'd like to hear them. I do like watching people doing similar things. So if you have recommendations, definitely love to hear them. Feel free to comment about it. So in any case, I'm going to head out for the evening. So thanks everybody for showing up, and I will see you all on Wednesday, where hopefully we'll finish this. So thanks everybody. Bye.